another one that's not using circles, but similar to the same kind of thing. Yep. The next one we're going to look at is actually a cone. I think this one's a little simpler, actually, but if you don't remember the volume formula of a cone, we need that for this one, though. So let's say we want to write the equation for the volume of a cone whose, what did I say, height is 3 times its radius. As a function of its radius. All right, so it's going to be a volume of a cone as a function of its radius, but this is a particular cone where the height is 3 times the radius. Okay? So let's start with what we know. Okay? So, what do we know? What can we write down? What relationships do we have in this problem that we're going to need? Yep. The height of the cone is equal to 3 times its radius. H equals 3r. Okay, that's key. What else do you notice in this that we're going to need? Yeah, volume formula for a cone. Anybody remember what that is? All right, 1/3 base times height, correct. And what is the base of a cone? Mm-hmm. So it's that. 1/3 pi r squared h. So, what do you suppose now, if I have a volume as a function of the radius, what do you suppose I need to do? Yeah, go ahead.
Substitute in 3r for h?
Mm-hmm. Yep, exactly. Because after I do that, v equals 1/3 pi r squared, and then instead of h, I write 3r. Notice now the formula for the volume that used to involve both r and h now only has one variable in the mix, right? Just the r. So if I simplify what I have here, now I've got a volume formula for my cone as a function of r. There's just r in that formula now. Okay? So this one, the simplifying is not quite as tricky as some of the other ones we looked at. What do we have to do here to simplify it up? Do you notice anything in there that's going to cancel or combine together, that sort of thing? Yeah?
The 3 and the 1/3.
Mm-hmm. They will cancel. Yep, the 3 and the 1/3. So v of r. Okay, so those are gone. And then what else is going to happen once I get rid of those? Yeah. Right, so it's going to be pi r cubed. That would be it. Okay, what if I wanted the volume as a function of the height instead of the radius? Okay, how would this change? Oh, question. Mm-hmm.
Why did 1/3 cancel?
Because 1/3 times 3 is 1. So that would just, yeah, so it'd be 1 pi r cubed, but yeah, you don't need to write the 1 then at that point. Mm-hmm. So let's try this again, except let's do it as a function of the height, and just see how it changes. So we're still going to start with the same information. H is equal to 3r. V is 1/3 pi r squared h. But if I want it to be a function of its height, then the formula that I have when I'm done can't have r's in it. It has to have h's in it, right? So that's going to mean my substitution step is going to change slightly. So how am I going to have to change things up to make that work then? Yeah, Josh.
Make it
Right, so this little h equals 3r, I'm going to have to change to r equals h over 3. I'm just doing a quick little algebra solve for r there. Because now, if I substitute that in for r, I'll have eliminated the r's and I only have h's. Okay? So that's going to be our next step here, is to take this volume formula again. And it's going to be 1/3 pi h over 3 squared times h. Okay, same idea, but again, it's what's the result that I want? I want to have h's instead. So here, and again, it's just a matter of simplifying this thing the rest of the way. So v of h, well, let's see. I'm going to have 1/3. When I square this h over 3, what's that going to become? H squared over 9. So what's this fraction going to be in front then? I got a 1/3 here, and I'm going to have essentially a 1/9 here. 1/27. Yep. The pi is still there, and then I'm going to have an h squared times an h, right? Because I've already used the 9 from here and brought it out to that fraction. So h squared times h, what's that going to be? H cubed. Okay, so that's acceptable, or I guess maybe a little bit cleaner. V of h equals pi over 27 h to the 3rd. So that would be doing it as a function of its height. Okay, so that's the idea with that. Okay, you're going to have to draw on some geometry formulas from the past. Anything too terribly complicated, and I will, like on a test or whatever, I will give to you. And I will let you know when we're reviewing for your test which formulas from geometry you should have memorized and which formulas from geometry that I would be giving to you. Okay? So we'll do that as part of our review. So, okay. So that's using those substitutions. I do have one more example that is similar in nature, but requires a little extra work. In this example, we might not have time to completely finish, so we'll kind of see how we do here. But I want to at least set it up, and then we can get back to it tomorrow. So let's say the lengths of the two legs of an isosceles triangle are 4 times the length of the base. Write a formula for the area of the triangle as a function of its base. Okay, so I don't want to dig into this one just yet, but I want you guys to start thinking about it a little bit. Okay, area of a triangle involves what two measurements that we will need to know? The base and the height. Okay, the one thing that I haven't made any mention of on here is the height. Okay, so be thinking about how can we take the information that we have right here and get something about the height going. Okay, there's a certain theorem from geometry that we use a lot that's going to help us there. Okay, I don't know what it is, but be thinking about it.